to take always perpendicular force to the surface area. F perpendicular divided by area is a fluid pressure. In that pressure will have different units. The SI units are what? Pascal will take, or Newton per meter square. Tell me all the units. 1 Pascal is equals to 1 Newton per meter square. 1 atmosphere is equals to how much? 1.013 into 10 power 5 Pascal. Otherwise 1 bar is equals to how much? 10 power 5 Pascal. And then 1 atmosphere is equals to how many bars? 1.013 bar we will take. And also 1 atmosphere is equals to how many torr? 760 torr. 760 torr. These are the different units of pressure we have discussed yesterday. And after that we have discussed about the density. Density is just nothing but mass by volume. We have to take the units will be kg per meter cube or gram per cc will have. Then after that relative density or specific gravity. What is the formula? Density of substance by density of water. Exactly at what temperature? 4 degrees Celsius. At 4 degrees Celsius, the density of water in Cj is how much? 1 gram per cc. 1 gram per cc. In the same way, in the kg per meter cube, it will be 1000 kg per meter cube. This is about the relative density, and then density of water at a particular 4 degrees Celsius we have discussed. Why? Because there the water will have the maximum density. And then after that we have seen the density of mixture problems. In that, for example, I have mixed two fluids of densities rho 1 and then rho 2 with masses m1 and m2. Then what is the rho mix formula? Rho mix is equals to at equal masses. Let tell that directly. What we will get? 2 rho 1 rho 2 by rho 1 plus rho 2. If masses are not equal, then what will get? m1 plus m2 into rho 1 into rho 2 by rho 1 m1 or m2 na? m1 plus rho 2 m2. That is about the density of mixture whenever we have mixed two liquids of masses m1 m2 and then densities rho 1 and rho 2. Then m1 rho 2 na? Yes, this is what we will get. Then whenever you see the two liquids again rho 1 rho 2 mixed with volumes and then v1 v2, at that time what is the formula you will get? Rho mix is equals to rho 1 v1 plus rho 2 v2 by v1 plus v2. If equal volumes, then what will get? Rho mix is equals to rho 1 plus rho 2 by 2. These are the different cases we have discussed yesterday. Next one is calculation of pressure. What is that? Effect. Till here only, no? We discussed yesterday. Effect. Yes. Effect. That's important. Effect of temperature and then effect of pressure. So, effect of temperature. First of all, whenever I raise the temperature, then what happens? Volume increases. Hence, what happens? Density will decreases. Why? Because rho is inversely proportional to V. Rho is equals to mass by volume. Then rho is inversely proportional to V. As the volume rises, then density decreases. It will decreases by how much? Rho dash is equals to, what is the formula we got? Rho by 1 plus gamma into delta T. That is the formula we got whenever it is decreasing means. Now, at the same time, whenever the pressure is increasing, volume decreases, density increases. Then rho dash is equals to, we got in terms of bulk modulus. Yes. So that what is that? Rho divided by 1 minus delta P by B. Delta P is a change in the pressure and then B is the bulk modulus of the any liquid whatever we have taken. This is about the effect of temperature and then effect of pressure. That's it now we have discussed. Next, calculating the pressure in terms of height. Calculating the pressure in terms of height. Calculating pressure in terms of height. What is the formula we will get? Pressure is equals to rho gh, that's it. But we will submerge one body inside of the fluid. At that time we will find out the pressure difference on the top surface and then bottom surface. So any liquid if I take, closed vessel I have taken, the vessel is closed, inside of that fluid is there. Now you have to find out the pressure on the bottom of the surface. Let me take the point P here. P means again you will get confused. Let me take that is A. A means area, again confusion. X, yes. It will be there always for us to help. So X I have taken. Now this point X is there from the top of the surface, otherwise height of the container is how much? Nothing but here H is the height of the container. I have taken closed vessel by the way. Now I have to find out the pressure at this point. So pressure at X, Px is equals to what will get? Generally what is the formula for us? Force by area. Pressure is equals to force by area. Who is applying force here? Weight of the fluid only. The weight of the fluid is the force here. On this point, who is applying force? Nothing but under my legs. Who is applying force means I am only applying, my weight only applying the force here. In the same way, here weight of the fluid is applying the force. Here the weight of the fluid is M I have taken. So that as it is force divided by area, perpendicular force by area, the force is how much here? Mg divided by area you have to take. So if I not mentioned about the mass, here I have given the mass, directly mg by A will get. If I mention about the density of the water, I have taken, and then length and then height of the container, like that I have taken. So what I can write here? Density into volume into G divided by A. So rho into volume, nothing but what I can write? Area into length. What is the length here? H is the length. So that AHG by A. A gets cancelled. What will you get? H rho G. That is a pressure at point X. Pressure at the bottom of the container we have taken. The container height is how much here? H. If here the container is closed, okay, then we got it as rho GH. For example, if the container is open, at that time what will get? Extra pressure will be there. What is that extra pressure? Atmospheric pressure. Atmosphere also will apply some pressure. Yesterday itself I said that. So that atmospheric pressure is how much here? P naught. If the container, the same container is open, the top end is open now, like this it is there. Again same height only, everything is same. The same container I am just opening it. So at that time on the surface what will be there? Nothing but atmospheric pressure will be acting always. Due to the atmosphere some pressure will be there on that. So that one is atmospheric pressure, another is what we got? Pressure due to the fluid, pressure due to the atmosphere. Together will be how much? Nothing but if the container is open, then Px is equals to what will you get? P atmosphere plus H rho G. Otherwise Px is equals to P atmosphere, nothing but what I can write? P naught plus H rho G. That is a formula whenever the container is open. Whenever the container is closed and then there is no air, nothing here. There is no air and then there is no gap, nothing. So at that time what happens? Nothing but the atmospheric pressure will be 0. For example, if I left some air and then I close the vessel means at that time also it will be there, pressure will be there. For example, if you are not filling this one completely, if you fill this completely without any air, at that time only at this bottom surface I will have the pressure due to the liquid only liquid. If I take, just gap is there here, if you see gap is there here. So even if I closed also, here air is there. It is not a vacuum. We are not removing the air there. So it is a air. So that air will have even atmospheric pressure. That the pressure due to the air plus pressure due to the water. So P naught plus rho GH will get. Completely if I filled without gap, nothing but at that time only what will get? Rho GH will get at the bottom. For example, exactly at the middle I asked. Then what will get? Rho GH by 2. That's it. There is no confusion in that. So that is about the pressure inside of a vessel. Yesterday bulk modulus problem I have given 20,000 problem. Have you solved that? How much answer you got? Approximately 11, 11 approximately. 11 point extra you will get. Yes. Actual answer is 440 by 39. Correct? 440 by 39. Right. Next, pressure difference we will see. In that pressure difference, first of all I have taken a cylindrical body inside of a fluid. At that time I have to find out the pressure difference on the top surface and then on the bottom surface. Why? Because here if you see that on the top surface we are having here less fluid, nothing but less pressure. On the bottom surface this much of height fluid is there, so that on that bottom surface we will have more pressure. So that pressure difference you have to find out here, the pressure difference at this one top surface and then bottom surface. Let me take the top surface and I will take it as 1 and then bottom surface I will take as 2. Now on the top surface tell me what is the pressure is acting. On the top surface, that is P1. What is the pressure acting on the top surface? Perpendicularly how much force is acting here? Obviously that whatever the fluid is there, that much only. So that what is the pressure here? Rho G into, what is the height here? H1 is the height. And also it is open, right? It is open, nothing but what will be acting? Atmospheric pressure, that is P0 will be acting. P0 plus rho G H1. Next on the bottom surface, P2 is equals to what will be there? P0 plus rho G H2. Now I want to find out the pressure difference, nothing but that is P2 minus P1 you have to do, that is P0 plus rho G H2 minus of P0 minus rho G H1. I am sending minus inside at a time. So here what will get cancelled? P0 gets cancelled. Then what I can take common? Rho G H2 minus H1. The difference between the heights of the top surface and then bottom surface gives you the height of the cylinder obviously. If I say this marker is there, from my head top surface is there at let me take 10 centimeters, bottom surface is there at 20 centimeters. So what you can say the length of the marker is? 10 only, right? 20 minus 10. Then it will give you the total height. So that is only I am doing here, H2 minus H1. Height of the cylinder how much I am saying here? H. If not also directly P2 minus P1 is equals to rho G into H2 minus H1. Otherwise what I can write, nothing but P2 minus P1, the pressure difference, the delta P we will take it as, that is equals to rho G into height of the cylinder. Clear? This height is different, that one is different. This is the height of the container. This one is what? Height of the cylindrical body, whatever we considered. Copy that. Clear? Next one, we will discuss something about this. Let me take, if I take a vessel like this and one more is this one is closed, enclosed in the bottom surface. Now I'll select different points here. Let me take point A and then point B and then point C. Now tell me, in which one pressure will be more? In which point, at which point the pressure will be same? So C. At which point pressure will be more? Why same? Why? Because here less water is there, no? Weight should be is equals to the pressure, right? Why it is having less weight here? Everything is water only. See that pressure is only depending on what? Height of the liquid column, density of the liquid, and then gravity. Is that depending on mass here? Is that depending on area of the vessel? It is not depending on the area of the vessel. That got cancelled already. It is not there. So that our pressure is purely depends on the height of the liquid column. Pressure purely depends on the density. So that here what I can write, if you see, all are at the same height only. If you take point A and then point B, point C, all are the same height only. And by the way, everything is water only here I have taken. So that what I can say, nothing but from the formula, pressure is equals to rho G into, at point A if I calculate, what is the height I said? H is the height. So that P naught plus what I can get? What I can get here? Rho G H, H rho G or rho G H I can get here. That is about the first one. Second one, point B. Point B also how much height is there? Same height H only. So that again what I can write? P naught plus H rho G. Again the same thing only. Third one also what I can write? PC also equals to what? P naught plus H rho G only. So that clearly I can conclude it as at all points at the same height the pressure will be same. Or how many ever points might be, but the same height from the top surface. And also, but here whenever you consider here the pressure will be different. Why? Because on this how much fluid is there? Only this much of fluid is there, and then that is at a different height from the closed end here. So whenever you consider at that time, at this point, the atmospheric pressure will not be there. Clear? So we'll leave about that, we'll study about that in Pascal's law. So here A, B, C different points are there. Each point is there at what height? Nothing but H height only. So that the pressure will be same at all the same level points. So that the pressure will be how much it is? P naught plus H rho G everywhere. And also one more thing is, whenever I consider the pressure here at this point, from all the directions, from each direction pressure will be same. You don't think that here the less water is there, nothing but here less pressure will be there, here more water, nothing but more pressure will be there. That and all is not correct. So one point if you consider, from all the sides pressure will be same only. And also the pressure on at any level will not depends on the shape and then area of the vessels. It will depends purely on the height of the fluid column, how much is there. So there is a more height, nothing but there will be more pressure. Less height means less pressure will be there. That's it. That is the difference between them. If we consider on the top surface only atmospheric pressure is there. Why? Because there is no fluid upside. But here what is the pressure? Nothing but P naught plus rho G H we have taken. Why? Because on this height is more. Here height is 0. So only directly P naught we got. So mainly you have to remember that the pressure will purely depends on the height of the column only. That will not depends on the mass of the water, how much is there above. Otherwise that will not even depends on the shape and then size of the vessel whichever we have considered. And that will depends on the density of course, so that P naught is equals to H rho G formula we got. So the pressure will be same at same level only. So if I consider this point here, then pressure will be same or different? At this point, only at this point. In this I'm talking about, let me take point D. Now tell me point D. Same pressure or different pressure? Different pressure. Why? Because here height is not same. A, B, C are at the same level, so only I got same pressure. For example, if I take the point E here, at that time I can say that PD is equals to PE. Why? Because both are at the same level. Let me take that is height H2, then this is also at height H2 only. So that our formula will be what here? P naught plus H2 rho G. Is same for the PE also. So it is just matter of height only, height of the liquid column where you are considering. If I consider all the points at this ABC, then all will have the same pressure. If I consider all the points exactly here, they will have the same pressure. So nothing but the level, horizontal level should be same. At that time pressure will be same. Clear? And also one more important thing is, whenever you consider any point, at that point pressure will be same in all the directions, irrespective of, for example, if this one I considered exactly in the middle. If I consider the point here exactly, if I consider the point here, now what happens? Nothing but people might be think that here less water is there, so only less pressure, from bottom more water is there, more pressure, like that. It's not correct. The pressure will be, let me take this is some height is y. At that time always how much height, how much pressure is there here? P naught plus rho g y only. From all the sides, from this side even, from this side even, from this side, every side the pressure will be same only. And also the points at the same level will have the same pressure. And also one more thing is, for example, if I consider the vessel here, in that vessel I am just taking a block here. Block is partially submerged of mass m. Now you have to find out the pressure at the bottom point x. Tell me what is that? Height of the fluid is here h. Now tell me what is the pressure at x? Px is equals to, what will you get? P naught plus h rho g. Okay, then what about the mass? Even this is also applying some force, right? How much force it is applying? Mg. It is having mass m, so that only it is applying mg force. All the forces you have to take, not only by the fluid, even I might be compress it by applying the piston here. Anything, but all the forces whichever are acting, atmosphere is applying force, so that only P naught we have taken. Fluid is applying force, so only we have taken rho g h. What about this mass? This mass also applying the force. How much force it is applying? Mg divided by the fluid surface here A. So mg by A will get. Clear, right? That is not only about the fluid. If you take any extra bodies also, by that also you have to take the pressure. That pressure will be obviously weight of the body divided by area only. Clear? Write that. First of all, note points. Surface? Illa. Mele. Illi. Pressure will be P naught only. Illinda. Illi. This one is only from the top only you are taking, you have to take the perpendicular force divided by area only. If I take this, only atmosphere is applying the pressure inside. Weight of the fluid is how it is acting mg downwards. It is not acting in the upward direction. Mg is acting downwards or upwards, fluid mg downwards. Then upwards nothing is there. Air is also having mg, that mg only causing the atmospheric pressure here. Clear? Write that. Write as a note point. Pressure at a point is same from all the directions. Pressure at a point is same from all the directions. Draw this diagram. Next point. At the points at the same level, pressure will be same. The next line, the fluid pressure depends only on the height of the column. The fluid pressure depends only on the height of the column. Irrespective of shapes and sizes of the vessels, and weight of the liquid above that points. Weight of the liquid above that points. If you see, at which point there is a more weight? At which point there is a more weight? Second one, right? Second one is having more weight. So that here this is having very less weight. So WA is not equals to WB, is not equals to WC. But even then what happening here? Pressure A is equals to pressure B is equals to pressure C. Why? Because it will not depends on the weight of the liquid, it will depends only height of the water column. Clear? Copy that. Third one also directly you copy. We will see the pressure height curve. Pressure height curve. For example, closed vessel. At that time what happens? What is the formula we got? Closed vessel means P is equals to what is the formula? Rho GH we got. So that rho G is constant only, obviously. Density of the fluid will not changes, and then gravity will not changes. Only height will be changing. Keep on. So that what I can say, P is directly proportional to H only. For the closed vessel, what I can say, nothing but pressure is equals to rho GH. So that this is in the form of y is equals to mx plus c only. Correct? Here intercept is becoming as how much? 0. Y is equals to mx. Nothing but what will get? Straight line will get. So that here pressure is directly proportional to the height. So that what will get? Nothing but from the origin you will get a straight line. For which one? Closed vessel or open vessel? Closed vessel. Closed vessel it is. Next one is, for example, if I open the vessel, at that time what is acting? P naught is acting extra. So that P is equals to P naught plus rho GH. Even I can write it as rho GH plus P naught. Now this is in the form of what? Y is equals to mx plus c. Nothing but intercept is not becoming as 0. At that time what happens? It will start from the origin or from the interceptor? From the intercept values it will start. So that from here it will start. Let me take here the value is P naught. So this is the open vessel. Angle is theta here, even here also angle is theta. Clear? So that the main thing is here, for example, if the vessel is open, at that time extra atmospheric pressure is coming. So our formula will be P is equals to P naught plus rho GH, we have to take the variation between the pressure and then height here. So pressure is directly proportional to height, along with that extra we are getting P naught. So our value is not starting from the origin, it is starting from P naught. It is like V is equals to U plus AT formula only. If you say V and then T graph, VT graph, then what I can write, V is equals to U plus AT. So what you will write, nothing but you will just draw the line like this. Why? Because it is starting from the value U. And then this one will be what? V is equals to U plus A into T curve. In the same way, the sound melena. So it is starting from some value, that is P naught, then P naught plus H rho g we got. So only first of all you have to take the initial value whenever it is a vessel is opened. Whenever the vessel is closed, at that time atmospheric pressure is not there. So directly what will get, nothing but P is equals to rho g H will get. P is directly proportional to H, so that only will get a straight line like this. Clear are two graphs? Yes. Copy that. Pressure and then height curve. Pressure height curve. Write a problem then. Find the pressure exerted. Raja, fan. Slow it. Find the pressure exerted below a column of water. Below a column of water open to the atmosphere. Open to the atmosphere at a depth. First one 10 meters, another is 30 meters. In terms of Pascal and then atmosphere you have to get. Open vessel or closed vessel? Open vessel they are saying. First one 2 into 10 power 5 means how much? 2 Pascal. 2 atmosphere. Four. Yes, correct. That's correct. Very good. Two atmosphere, 4 atmosphere. Correct? Huh? First answer exactly in the Pascal is 2.013. Na? 2.026. 2.026 into 10 power 5 you will get. Correct? Huh? Second one is 4 point approximately 10 power 1.013 ಬಿಟ್ಟಿದ್ದೀರಾ? ನೀವು ಬಿಡಕ್ಕೆ ಫಸ್ಟ್ ಇರ್ತಾರೆ. 10 meters height. The vessel is open they are saying, so that P is equals to P naught plus rho g h. P naught is exactly 1.013 into 10 power 5 plus rho is how much? 10 cube 1000. G is 10, height is how much? 10. So that how much it will be? 2.013 into 10 power 5. So approximately what I can say? 2 atmosphere. 2 atmosphere I can say. This is about the pressure at 10 centimeters depth. Then if you say the pressure at 30 centimeters, next one 30 meters, I'm sorry, 30 meters depth. So P30 is equals to again 1.013 into 10 power 5 plus how much will get? 3 into 10 power 5. Then this will be 4.013 into 10 power 5, approximately how much? 4 atmosphere. This is in Pascal, in atmosphere. In either way you have to get the answer. Clear? That's very easy problem. Next one is U-tube problem, we'll see. A U-shaped tube is there. YouTube andre nim YouTube alla, nam YouTube. ಫಸ್ಟ್ ಅದು ನೆನಪು ಬರುತ್ತೆ, ಬಟ್ ಇವು ನೆನಪು ಬರಲ್ಲ. ಇನ್ಸ್ಟಾಗ್ರಾಮ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಸಿ, ಓಕೆನಾ? ಇನ್ಸ್ಟಾಗ್ರಾಮ್ನೇ ಭಾಳ ಮಿಸ್ ಆಗ್ತಾಯಿದ್ರು ಪಾಪ ನಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಸು. ಏನು ಉದಯ್, ಫಾಲೋವರ್ಸ್ ಎಲ್ಲ ಸೂಸೈಡ್ ಮಾಡ್ಕೊಂಡಿದ್ರು ಏನು? ಪ್ರಜ್ವಲ್ ಮೇನ್ಲಿ ಏನನಿ ಅಂದರೆ ನಿಮ್ಮ ಹತ್ರ ಫೋನ್ ಇದ್ದಾರಾ? ನ್ಯೂಸ್ ಹೆಂಗೆ ಗೊತ್ತಾಗಿದೆ ನಿಮಗೆ? ಪೇಪರ್ಗೆ ಬಂದಿದ್ದಾರಾ? ಅಷ್ಟು ನ್ಯಾಷನಲ್ ನ್ಯೂಸ್ ಆಗಿದೆನಾ? ಉದಯ್ ಫ್ಯಾನ್ಸು ಮಾನಸಿಕ ರೋಗಿ ಆಗಿದ್ದರು. ಪ್ರೊಫೈಲ್ ನೋಡಿದ ಆದ್ಮೇಲೆ ಆಗಿದಾರ? ಏನು ಈ ಮಧ್ಯೆ ಗೌತಮ್ ಕೂಡ ತಗೊಂಬರ್ತಾ ಇಲ್ಲ ಫೋನು ಪಾಪ. ತುಂಬ ಫ್ಯಾನ್ಸ್ ಎಲ್ಲ ಮಿಸ್ ಆಗ್ತಾಯಿದ್ರು. ಏನು ಶ್ರೇಯಸ್, ಎಲ್ಲರ ಅಕೌಂಟ್ಸು ನೀವೇ ಮ್ಯಾನೇಜ್ ಮಾಡ್ತಾಯಿದ್ವೇನು? ಡಿಫ್ರೆಂಟ್ ಫ್ಲೂಯಿಡ್ಸಾ ಸೇಮ್ ಫ್ಲೂಯಿಡ್ಸಾ? ಕಲರ್ ಚೇಂಜ್ ಆಗಿದೆನಾ? ಇದು ಆಯಿಲು, ಇದು ವಾಟರ್ ಅನಿಸುತ್ತೆ, ನೋಡಬೇಕು. ನೋಡ್ತೀನಿ ತಡ್ರಿ. ಒಂದು ವಾಟ್ರು, ಒಂದು ಆಯಿಲು, 12.3 mm, 135 mm. ಏನು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ನಮಗೆ. ಉದಯ್ಗೆ ನೋಡಿ ನಮ್ಮ ಕಣ್ಣು ಹೋಗಿದೆ. ಅವ್ರ ಫ್ಯಾನ್ಸ್ ಎಲ್ಲ ನೋಡಿಲ್ಲ ನೀ ಸೂಸೈಡ್ ಮಾಡ್ಕೊತ ಇದ್ರೆ ನಾವು ನೋಡ್ಕೊಂಡು ಸೂಸೈಡ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಏನೋ ಅರ್ಥ ಆಗಿಲ್ಲಪ್ಪ. ಬಿಟ್ಟು ಹೋಗ್ಬೇಕಾ ಕಾಲೇಜ್ಗೆ? ಆವಾಗ ಮನಃಶಾಂತಿ ಇರ್ತಾರೆ ನೀವೆಲ್ಲ. ಎಸ್, 135 mm. ರೈಟ್. ಆಯಿಲ್ ಡೆನ್ಸಿಟಿ ಆಫ್ ಆಯಿಲು ನಾನು ಕೊಡ್ತೀನಿ. Write a problem. For the arrangement shown in the figure, find the density of oil. Find the density of oil. Find that. Let's check who will do the answer. This is 135 mm. This one is 12.3 mm. The difference in the levels is 12.3 mm. And then here this is the 135 mm. This YouTube question came in the previous year, I think 2018, like that it came. I'll tell you at which year it came. Draw the diagram properly. Draw the levels properly first of all. Yes, it came in 2017. Same kind of problem. Solve that. How to find out the oil density here? Density of oil you have to find out. How much? No, no. Take the units properly. 135 mm, 12.3 mm I have given. Correct, 12.3 mm only. ಹೆಚ್ಚು ಹೆಚ್ಚು ಎರಡು ಕೂಡ ಸೇಮಾ ಅಲ್ಲಿ ವಾಟ್ರೇ ಇಲ್ಲ ನೆಕ್ಸ್ಟ್ ಟರ್ಮಲ್ಲಿ ಫಸ್ಟ್ ಟರ್ಮಲ್ಲಿ ಆಯಿಲ್ ಲೆವೆಲ್ ಜಾಸ್ತಿ ಇದೆ ವಾಟ್ರ್ ಕಡಿಮೆ ಇದೆ ಅಲ್ಲಿ ನೋಡು ಬರೇ ವಾಟ್ರ್ 135 ಇದೆ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ವಾಟ್ರ್ ಮೇಲಿಂದ ಇಲ್ಲಪ್ಪ ಅರ್ಧದಲ್ಲಿದೆ ವಾಟ್ರ್ You can apply equal points, that's it. Pressure is equal at the equal level, that's it. Then you will get the answer. Density of oil you have to find out. Shall I do? See that here let me take 2 points just below the oil level and then just below the water level. Inside also everything is water only, here also water only. So that what I am doing nothing but I am taking this as point A and then point B. If I take point A and point B, both are the same level. Whatever above might be oil, above might be water, anything I am taking inside of the water level only. See here, till here oil is finished. Inside of the water I am taking point A and then inside of the water only I am taking point B. So can I say that PA is equals to PB? Same level, same pressure will be there. So that PA, what will be there at PA pressure will be what? P naught plus. Here atmospheric pressure is acting. By the way, this is open end. P naught is there. Even here also P naught is acting. So that what I can say nothing but P naught plus rho of which one you have to take? Oil, right? So that rho of oil into H nothing but what is the height? Total height is how much here? 135 plus 12.3. How much that will be? 147 point how much? 3. This is the height. Total height of the oil. Why? Because height of the oil they have not given. They have not given the height of the oil. Instead of height of the oil, they have given height of this liquid here. So that will be exactly equals to this one. This empty space height they have given, that empty space is exactly equals to this one. Totally will be how much? Nothing but here 135 plus 12.3 nothing but 147.3 mm. Mm nothing but what you have to take it as 10 power minus 3 you have to take it. Then pressure at point B. At this point, the pressure will be how much? P naught plus. Again atmospheric pressure is there. See that water is there from only here to here only. So that P naught plus rho of water you have to take, rho of water, rho into G into height is how much here? Height of the water column is how much? Only 135 mm. So that 135 into 10 power minus 3. Correct? Then find out the rho of the oil. Here P naught plus, right? Yes, P naught gets cancelled here. G I missed, I think. Rho of oil is equals to G also gets cancelled, right? Both the sides. G also gets cancelled. Then what is remaining here? Rho of water into 135 mm divided by 147.3 mm. 10 power minus 3 gets cancelled here. Rho of water is how much here? 10 cube you have to take. That into 135 by 147.3. Tell me how much answer you will get. What is the answer you get? 0.9 into 10 power 3, na? Yes, correct. That's correct. Very good. I'll explain that. First of all, find out the answer, final answer. The exact answer is 916 kg per meter cube. Correcta? Listen here, I will explain again neatly everything. So mainly for this kind of problems, first of all you have to consider the level, same level, anywhere, it might be anywhere. I can even consider here also, at the bottom also I can consider, but I have to consider this height also, I don't know that height. So only wherever you know, you just stop there and then you just consider the points. So if I consider exactly at just the bottom of the oil, I am not even going into the oil here, I am not even going into the water, inside I am not going, just interface only I am taking. At that interface I am considering point A and then point B, both are at the same level. At the point A, what you have above the point A, you are having only oil, above the point B you are having only water. So that both are at the same level. I said in that note points, the pressure will purely depends on the height of the water column, otherwise height of the fluid column. So that I can clearly say that PA is equals to PB. Why? Because they are at the same level. So pressure, here both the ends are open here, we call it as limbs also. In some of the problems they will mention it as limbs or arms. So in the right side arms, what is there? Right side limb, what is there? Nothing but water is there. In the left side arm, what is there? Oil is there. Both are having different densities. You have to find out this oil density only. For that purpose, first of all you have to take separately pressure at A, separately pressure at B and equate both. Why? Because both are at the same level. So that for the pressure at A, already atmospheric pressure is acting here, that is how much? P naught plus rho into rho of which is there above the point, oil is there, that you have to mainly remember. You should not consider that as a water, just below the oil level you are considering. So that rho of oil into G into what is the height? Nothing but we don't know the height here. Instead of this height they have given this height, that's it. Both are same only. So that how much you will get? Nothing but that is 12.3 plus 135 into 10 power minus 3. That is the pressure at point A. Next, whenever I consider the pressure at point B, above the point B what is there? Only water is there, and above that free air is there, atmosphere is there here. So that what I can consider? Nothing but above point B, how much level water is there? Nothing but only 135 mm water is there. So that again that is open to the atmosphere. So that P naught plus rho of water you have to consider here, G, and then height of the water column is how much? Only here 135 mm, 135 into 10 power minus 3. That is what you will get PA and then PB. What I said, you have to equate them. Whenever you equate them, at that time what happens? Nothing but P naught and then P naught gets cancelled here, G and then G also gets cancelled. Only what will be remaining for us? Rho of oil you have to find out, that into 12.3 nothing but 147.3 na, 147.3, 10 power minus 3 also gets cancelled here. So only what is remaining? Nothing but here rho of water. Rho of water is how much? 10 power 3 into 135. Then your answer will be rho of oil is equals to 916 kg per meter cube. That's the answer for that. Same kind of problem came in the 2017 exam, NEET exam. Shall I give that? 2017 problem. A YouTube with both ends open, to the atmosphere, a YouTube with both ends open to the atmosphere is partially filled with water, and oil which is immiscible with water, immiscible nothing but we cannot mix them, which is immiscible with water, is poured into one side, until it stands at it stands at a distance of 10 millimeters above the water level. 10 millimeters above the water level. Above the water level. On the other side, meanwhile, the water rises by 65 millimeter. The water rises by 65 millimeters from its original level. Then density of oil is. Here what happening, nothing but here I have given the equilibrium state, but here they have not given the equilibrium state. They are just giving that the water level is changing from initial to final. For the problem, you have to only consider the final level, that's it. They might be confused in whichever way, you have to consider only equilibrium state. When you obtain the equilibrium state, nothing but after the change in the levels only. After change in the level, what happening, you have to observe mainly. So, draw the diagram. How much? 866. 928 is the correct answer. 928 is the correct answer. Try that. Draw the diagram properly. Understand the question first of all. Apply the pressure at PB and then PC, you will get the answer easily. Nine? 910 na? 928 approximately. Indirectly height of the water is how much here? 140. 65, 130 plus 10 will be how much? 140 is the height of the oil. Then you will get the answer. 928 is the exact answer. Yes, 928 is the exact answer here. Then why did not get first? I said already, in whichever the way they have given, in whichever the difficult conditions they have given, always you have to consider the two levels exactly at the interface, then you have to apply the equal pressure, that is it. See that here, they are saying that they are pouring first of all oil inside of the water, on the water they are pouring. Before they are pouring the oil, what happening, nothing but the water was there only up to this much level, only this much level it was there. Whenever they pour the oil, due to the weight of the oil, what happening, nothing but the water level is rising. That water level is rising to how much, nothing but again 65 mm it is rising. That is what the question they have given. And also given indirectly the height of the oil, the difference between the oil column and then water column is how much they said, 10 millimeters. Nothing but the height of the water column will be, oil column is how much, nothing but 65 plus 65 plus 10. From here to here only, no, however, same only. So that is how much, 140 is the height of the oil, write that separately, height of the oil is 65 plus 65 plus 10. Then that will be how much, 140. 140 mm is the height of the oil column. And then height of the water column is how much, 65 plus 65. You should not consider about the, you should not bother about the initial conditions. Always you have to take whenever it is reaching the equilibrium state. So that height of the water column is how much, nothing but that is 65 plus 65, that is 130 exactly, 130 mm. Now I said always they might be given any problem, you have to take the point at the interface. At the interface, first interface is this one, point B. At the same level you consider the point C also. Now you have to apply the equal pressures at B and C, then you will get the answer easily. So that the pressure at B, nothing but B is below what, oil here. So that by the way it is open to the air, so that atmospheric pressure will be there on both the sides, P naught and then P naught. Now what I can write, nothing but PB is equals to P naught plus rho of which one, oil, and then height of the oil and then G. That is about the pressure at point B. So that what I can say this one as P naught plus rho of the oil, I have to get to know. Height of the oil is how much I said, 140 millimeters. So that 140 into 10 power minus 3 into G. That is what the PB I got. Next PC, what will you get the PC? PC means Priyanka Chopra. At PC, what will you get, nothing but pressure at C is atmospheric pressure plus what will you get, height of the water column. What says, are you okay? PC means who? Who is PC? Pressure at? Yes, pressure at point C, not Priyanka Chopra. So PC is PC only. Why? Because Mick Jonas will get again angry. If you apply the pressure on PC, then Jonas will get angry. So PC is P naught plus what you have to take, rho of the water, G, and then height of the water. Okay, it's okay, cool. People, come to the class. 10 power 3 G, and then height of the water column is how much here? 130 mm. So that PB is equals to PC, I said, what will get cancelled here? P naught gets cancelled, G gets cancelled, 10 power minus 3 also gets cancelled. See, always you just remember that rho into height is equals to rho into height, that's it. There is no need to write this much of equations and all. Just this side rho h is equals to this side rho h, that's it. You will get the answer there only. So that whenever I say PB is equals to PC, then what is there, only rho of oil into 140 is equals to rho of water is how much, 10 power 3 into 130. Everything gets cancelled there whenever you equate. Then rho of oil is how much here? How much? 9? 26, 28, yeah, whatever. 928 kg per meter cube. Shall I give one more? Very easy problems, but people will get scared by seeing this. The YouTube in figure contains two different liquids in static equilibrium. The YouTube in figure contains two different liquids in static equilibrium. Water in the right arm and oil of unknown density rho x in the left arm. Oil of the unknown density rho x in the left arm. If L is equals to 135 mm, then find L is equals to 135 mm and D is equals to 15 mm. Then find density of oil. Same problem again, nothing is there. L is how much I said? 135. Then D is equals to? Yes. Find out the density of oil. Find the density of oil, and after the lunch also, my class only, we'll discuss the Pascal law then. What is the answer? 111. Exactly how much you are getting? 900 kg per meter cube. ಉಲ್ಟಾ ಎಲ್ಲ ಉಲ್ಟಾ ಆಗುತ್ತೆ. ಅದೇ ಪಿ ಸಿ ಬಗ್ಗೆ ಜಾಸ್ತಿ ಯೋಚನೆ ಮಾಡಬಾರ್ದಾನೆಂದೆ. ಮೈಂಡ್ ಉಲ್ಟಾ ಆಗಿದೆ. ರದೀಪ್ ಕಾಪೇರ ಏನ್ರ ಲೇಸಸ್ ವಸ್ತು